All right, so what we're going to be doing today is we're going to continue on with our look at the t-test. So we are now in the thick of hypothesis testing. We introduced the t-test last time and looked over why we need the t-test, and it has everything to do with the fact that we usually don't have access to anything, any knowledge about the population that we're studying. So we have to go off what the sample tells us about that population, and that moves us into t-test territory. So this morning, for the first hour, we're going to finish up our look at single sample t-tests. This is one of the three types of t-tests that we're going to introduce. So today we'll see how to actually calculate it all the way through. Last time we introduced the idea of it. Today we're going to take a look at how to actually do that. So we have all 5 portions of the hypothesis testing procedure down, so we know how to do each of those. So you're completely ready to do this alone. And now that we've entered more realistic statistical calculations where a lot of the assumptions are no longer there, the math tends to take a step up in difficulty because those assumptions were made to make the math easier. So once those assumptions are gone, the math gets a little bit harder. So now it's perfect time to switch over to a dedicated statistical package. It's time to switch over to SPSS and let that statistical package do the calculations. So that's also what we're going to do today. We're going to introduce SPSS and start using it in order to do those calculations, turning all of those difficult calculations over to the robots, over to the computer, and leaving us to do the important human aspects of it, which is number one, figuring out what the question is, how to format that data, and then importantly, once the output is given to us, figuring out what does that output actually mean. So we're going to revisit Harlow and his infant monkey attachment study, and then we're going to see how to do that study for real using SPSS. So we're going to just briefly revisit hypothesis testing with the t-statistic. Then we're going to jump into SPSS, and then we'll have some in-class practice, time to work on those skills. All right, so before we begin actually using these programs, just want to reiterate, we mentioned this at the beginning, but just in case you forget, SPSS is installed on computers here at IUSB. At the very least, I got to double check on the computers in this room, but in the psych lab, they have SPSS installed on their computers. So you can do and use SPSS here at IUSB. You have Excel here at IUSB as well on all the computers. However, you also might want to do some of your homework and studying at home. So just so you know, you do have access to both Excel and SPSS at home. So Excel you can actually install for free at home. There's various different versions of it, I believe. But SPSS, you actually cannot install that on your home computer, but you can communicate with our servers here using IU Anywhere, and that is the system by which you can access it. So I just want to be sure that you're aware of that. We'll go through how to sign in for IU Anywhere today. Because if you do install SPSS, if you go to IUware, you can download the SPSS installer. You can install it on your computer. You will get a 2-week trial, and then you will have to pay a subscription fee. That's not what you need to do. If you want that, you can go that route, but you do have a free access option. I just want to make sure you're aware of that. And we'll go through how to get to that today. All right, so hypothesis testing with the t-statistic, let's set this up. So once again, we're going to revisit the classic study that Harlow and Zimmerman did on infant monkeys. So one mother was made from wire mesh and contained a baby bottle from which the other infants could feed. The other mother was made from soft terry cloth and did not provide any access to food. Harlow observed the infant monkeys and recorded how much time per day was spent with each mother. In a typical day, the infant spent a total of 18 hours clinging to one of the two mothers. If there was no preference between the two, you would expect the time to be divided evenly with an average of 9 hours for each of the mothers. So notice here, we have some information, but it comes from the sample. So they were watching the sample of monkeys, and these monkeys spent about 18 hours a day with both mothers, with each of them. So this is our hypothesized mean for the population. So if these are typical monkeys, and they spend 18 hours a day with both mothers, if they have no preference between the mothers, they'll spend half the time, 9 hours with one, half the time, 9 hours with the other. So we don't know how much time they actually spend with the mothers. But we do know that if the null hypothesis is true, and there is no effect of the type of mother, there's no preference for the mother, we know that in that situation, they'll spend 9 hours with the terry cloth mother, 9 hours with the wire mesh mother. Okay, so this again, remember the example of the wage gap. If you just Google what the wage gap is, you will get disparate figures all over the place. It goes as low, I believe, as 49 cents per dollar, all the way up to like 99 cents per dollar. So it is all over the place. People are not sure what the actual wage gap is. However, we do know that under the null hypothesis, if there was no effect, if there was no wage gap, we would know what that would look like. It would be $1 per $1 women earning per every dollar that males earn. So the hypothesized mean is just that. It's a hypothesize, it's an idea, it's a speculation of what would happen if the null hypothesis was true. All right, so suppose we have a sample of 9 infant monkeys. So we have 9 monkeys that we run this experiment on, and they average 15.3 hours per day with the terry cloth mother. Is this result sufficient to conclude that the monkeys spent significantly more time with the softer mother than would be expected if there were no preference? Another way of saying that is this difference sufficient to conclude that the population of monkeys prefers the terry cloth mother? That's what significant means. A significant difference means that what's true of the sample is also true of the population. So for this, we're going to use a two-tailed test with an alpha of 0.05. All right, so we're going to go through the steps for this. It's still the same 5-step procedure, even though we're using SPSS. Still those same 5 steps. So the first thing we do, and this has nothing to do with SPSS, we got to restate the question as a research hypothesis and a null hypothesis about the population. So we've done this a few times. Let's see it one more time. We want to know, is there a preference for one of the mothers? Is there a preference for the terry cloth mother or for the wire mesh mother? That's the question we're interested in. And the research hypothesis is that there is a preference for one of the mothers. And if there is a preference for one of the mothers, that means that the time spent with the terry cloth mother, the mean time spent with the terry cloth mother, does not equal the mean time spent with the wire mesh mother. That's the definition of preference. One of them has more time than the other one. And because we know that they spend 18 hours a day with both mothers, we know that a preference is going to come out if the terry cloth mother does not equal 9 hours. If the time spent with the terry cloth mother is not 9 hours. So if the time spent with the terry cloth mother is 10 hours, that means terry cloth gets 10, wire mesh gets 8, preference for terry cloth. If the time spent with the terry cloth mother is 4 hours, that means terry cloth mother gets 4, wire mesh mother gets 14, preference for the wire mesh mother. As long as it's not 9 hours and 9 hours, there's going to be a preference for one of the mothers. That's your research hypothesis. Your null hypothesis is that there is no preference between the two mothers, and that would mean that the time spent with the terry cloth mother is going to be the same as the time spent with the wire mesh mother. We know from the question that they spend 18 hours a day with both mothers. If there's no preference, they'll spend 9 hours per day with both mothers, 9 hours with the terry cloth mother, and that is our hypothesized population right there. So maybe that population exists of no preference, mother-loving monkeys, right? But that's our hypothesized population. Is that the population that they belong to? All right, step 2, determine the characteristics of the comparison distribution. We learned how to do this in chapter 6. Very nicely, SPSS will do this for us. So SPSS will now calculate the characteristics of the comparison distribution for us. We just need to know where to go and find that information. Set a cutoff sample score or critical value. So these are your lines in the sand. SPSS, where'd it go? Will not do this for you. So this is one of the pieces of information that SPSS will not give you. However, SPSS will help. And I'll show you how it's going to help, but you are going to have to do a little bit of extra work with the cutoff sample score or critical value. Determine your sample score on the comparison distribution, determining where your sample actually is on that T distribution, that T distribution that is now your comparison distribution. Well, SPSS will do this for you. It'll actually calculate that T statistic instead of the Z statistic. It'll calculate that T statistic for you. And then finally, step 5, you got to do on your own. But let's go through steps 2 and 4 right now. So for this, we're going to open up SPSS. I'll show you how to do that in just a moment. If you haven't already, I suggest go to Canvas, check out the data in 08A practice June 10th. And for all of these slides, not only is the video going to be posted, but we also have screen grabs for like every kind of step along the way once you actually get into SPSS. So you got that as well. So hopefully you can follow along and do it live here with me. All right, so if SPSS is installed on your computer, then what you want to do, and one way to do this, get rid of all this, you would just basically search for that program. So if SPSS is installed on your computers, just go to search here. If you type in SPSS, it'll pop up that it's installed on your computer. It's probably installed on your computers here. One thing to be aware of, it will open even if you don't have the subscription and just basically not let you do anything. So bear that in mind if you're ever using SPSS on a computer and just nothing is working. It doesn't allow you to run any tests, any sort of analyses. That is when it is basically not allowing you to use it because it doesn't have that subscription. So what you want to do is you want to go to 1IU, and from here you can search for IU anywhere. So anywhere is spelled W-A-R-E, so it's N-E-W-A-R-E. And this is the cloud computing solution for you. So as long as you got a computer, as long as you have installed the little Citrix receiver, and we'll mention that, and you have internet access, you basically have access to a multitude of different programs. So you search for IU anywhere. You can click start right here. You can also Google it and it'll take you to the exact same location. You click log in. You use your IU username and passphrase. So I'm just going to log on here. I already got mine in. Got that push notification. So you sign in just the way that you would sign in on any of your devices. All right, and you'll see this little thing here that's called the Citrix Receiver. That needs to be installed on your computer if you are going to use IU anywhere. So your computers here should have it installed. When you do this at home, make sure that you have installed it on your home computer as well, and that will it does possibly take a little bit of fiddling to do it. Okay, so sometimes you have to enable access. Sometimes you need the administrative password. There's a lot of things that can go a little bit wonky with the Citrix server. So I highly recommend make sure that you got that up and running because we're going to be using SPSS a lot in the coming weeks. And if you have any issues, go to the IT help desk here and they can help you straighten that out. All right, so let me just check around. Has everybody gotten into IU anywhere? All right, let's see if we have some. Okay, so if you get to that page that says detect Citrix Receiver, just click on that button to detect the receiver, and it should, and just click on OK when it says access it using this link, and that should take you into this area over here. So you're in, you might not see any apps, that is fine for the moment, because that is one of the tricky things about IU Anywhere. So you're at IU where? You want to go to Anywhere. That's the wrong one. So if you just Google IU Anywhere, that's the one. There. On your home computer, you will need to install the Citrix Receiver. If you can't do it right now, you can use the light version, which is, we'll use it in a web browser. All right, so some of you are installing Citrix Receiver. While that's being done, I just want to point out one of the kind of weird design decisions. And I can see why they did it, but at the same time, it can be a little bit confusing for new users. When you open up IU Anywhere, you'll be taken to this page. This page indicates or has a list of your favorite programs. So right now, if you're a first-time user in IU Anywhere, you will get to this page and it will be empty. So don't worry right now if it's empty. What you want to do is you want to go up here, and here where it says apps, if you click on that, it will take you to a list of all the apps that they have. Now, as you can see, there is a ton of programs here that you have access to for free. As long as you got an internet connection, you can log into IU Anywhere and you can use all of these on your computer at home or anywhere else you have an internet connection. So the easiest way to find SPSS is just to search for it. So if you put in SPSS, the one that you're looking for is these ones here with the little sum of alpha and division. You can either use version 24 or version 25. They're virtually identical. I think I have 24 favorited, but you can do either or. And when you click on details here, let's go to 25. If you click on details, that's where you can add it to your favorites. So I highly recommend add it to your favorites. That way when you pop in, it'll go to your favorites automatically, and there will be SPSS waiting for you. And then once you have it in your favorites, we can click on it. Let's try 25 here, SPSS 25. If you click on it, it will open up SPSS. So it'll connect to your to our servers here, and it'll open it up, and you will have access to SPSS. It might take a moment or two depending upon your connection speed, but we should have SPSS going here in just a moment. There it goes. All right, so let's make sure that everybody's gotten to that part. All right, so has anybody not been able to find the SPSS program and start to get it booted up? Okay. That is probably coming for your IT department. I would recommend sign in here using your IT password so you can follow along with it. All right, so I'm going to wait until a few more have it ready to go and open. Okay, so you're in on it here, so on your computer at home? Or
Yeah.
Okay.
Doing special.
Yeah, just click open.
And it went to this stuff.
All right, so it looks like most of you have made it in. So when you open up SPSS, first place that it takes you to, or one of the windows that immediately opens, is this window here, which is your kind of welcome window, your SPSS Wizard. And this one, just a couple of things to point out about it. Let's see if I can get it onto the screen. Almost. All right, so this is where you can do a bunch of different things with SPSS. One of the important things here is that you can save your data sets, save your analyses, and that is very useful later on when you're doing very complicated analyses that might take you a while to set up. You can actually save those so that you don't have to continually update and redo your analyses. Very importantly, though, hopefully I can get this on the screen. No, I gotta go smaller. I almost get it. I can almost get it. All right, won't spend too much time on that. One of these buttons here, I think is this one here, is tutorials. SPSS is very widely used. So there are, number one, tutorials in SPSS. So if you ever are having difficulty running a test, in the future, if you're ever running a test that we didn't go over in class, there are tutorials in the program itself in order to help you run those. SPSS also has tons of how to do videos on YouTube from a variety of different sources. So oftentimes when I'm doing an experiment that requires a statistical test that I haven't done before and I don't know how to implement in SPSS, I will just go to YouTube, watch a 7-minute tutorial video, and be off and running. So be aware of that. There's a lot of resources for SPSS. All right, so I'm going to close that. So this is now the data entry data editor window of SPSS. So this works a lot like Excel. You're going to find out that a lot of the shortcuts for Excel work here. It's set up in columns and rows, just like Excel. So this is where we're going to put our raw data. And that is one of the first really, really important things to know about SPSS, is that you need to have raw data, otherwise you cannot use SPSS. So if you've opened up the Excel sheet, there's the raw data right there. And it's important to remember that in order to use SPSS, you need the raw scores for each of your subjects. When we were doing it by pencil and paper, we were able to get away with just having the mean, just having the sample variance, just having those summary statistics. In order to use SPSS, you need to have the raw scores. So you need to know that monkey number 1 spent 17.2 hours with the terry cloth mother. You need to know that monkey number 7 spent 11.51 hours with the terry cloth mother. You need that raw data. If you don't have it, unfortunately, you can't use SPSS. But we do have it here. So the first thing we're going to do is we're going to highlight these scores here, these hours that our monkey spent with the terry cloth mother, and we're going to copy them, and we're going to paste them into SPSS. So copy them in Excel, so highlight and copy, and then move back to SPSS. And you are either going to be able, depending upon your browser, you are either going to be able to go straight into the data editor, press Control V and paste it. If you cannot do that, like I'm not able to do that on my computer right now, you will notice these three little lines up here. Actually, about, yeah, so those three lines right up there, you see that black little tab there with the three white lines. If you go up to that, it'll turn into that little Citrix Receiver circle. If you click on that, it'll give you these options, which includes Open Clipboard. And if you click on that, you can then paste your scores into the clipboard, and that makes it accessible to SPSS. So don't ask me why this design flaw, in my opinion, exists in this way, that you can't directly copy into SPSS. For some browsers, you have to copy into this basically middleman here, close it, and then all of a sudden, you should be able to copy it. There we go. You'd be able to copy it straight into SPSS. Okay, so that is the first move. We need to get our data into SPSS. All right, so does anybody not have those scores in SPSS? Everybody's got those? Everybody's. Mm-hmm. No, we just want these. Oh. One second here. Let's undo that and fill it in. So, yeah. Get that. All right, so we have our data in SPSS. Now we're going to start this, or look at t-test with rather simple analyses that we're going to be done with in a few minutes and then move on to the next analysis. Most psychology work, however, isn't like that. Most psychology work, you'll work on it for more than a single day. And because of that, we need to do something about the name that SPSS has chosen for our scores. So SPSS assigned our scores a variable name, and it assigned our scores a variable name that's perfect for a computer. It assigned var 00001. Now var 00001 is a great variable name for a computer because it'll be able to remember exactly what that is. If you showed up to this program tomorrow and reopened this file and saw var 00001, you're not going to remember what it is. And sometimes when you're working on an experiment and you want to interpret the data, you're not going to remember what it is either. So we need to change that name there to something that's going to make sense to our human minds. And in order to do that, we're going to go here to variable view. So this data editor has two views. We're right now in data view. That's where you can input your data. We're going to click here on variable view. And that's going to take us to the variable view here. And we're going to click on var 00001. And we're going to change that into something that can jog our memory. And we're going to change it into tear cloth. As we go through SPSS, I'm just going to make certain recommendations because as powerful as SPSS is and as wonderful as SPSS is, it does have some idiosyncrasies that are weird. One of those is when you're naming the variables. So SPSS will always work if you name your variables 8 characters or less. If you go beyond that 8-character limit, some of the analyses will work, some of them won't. And I cannot memorize which ones will work and which ones won't. Why only 8 characters? This is like a holdover from the 90s in computing when you had to shorten. Basically, it's a holdover from ancient days in computers. But this is the 25th version of SPSS, and it really looks like each version was built on top of the other version. And sometimes little things like this stay in there. So rather than saying terry cloth, we're going to put in tercloth, Tercloth. We're good. It's 8 characters or less. So that's what we're going to use. The other thing is that you want to keep in mind is SPSS has some rather weird naming conventions, things that it will not allow you to name variables. So for example, if I wanted to call this 9 monkeys, right? If I wanted my variable name to be 9 monkeys, SPSS will not let me do that. And it'll give me this error message or warning message, and it'll say variable name contains an illegal first character. So sometimes when you try to name, as you're learning SPSS, sometimes when you try to rename your variables, you'll get a message from SPSS. When that happens, just read it, figure it out. Oh, variable name contains an illegal first character. I guess I can't use numerals as a first character, and then just go back and fix it up. In this case, we're going to go to tercloth. All right. Click on back to data view, and you can see that it has updated the name of our variable now to tercloth, and that is something that our human minds can understand. If we came back to this file, this data set tomorrow, and we saw that that variable was labeled tercloth, that's enough for our human minds to say, oh, right, that's how many hours our monkey spent with the tercloth mother. Okay, I get it. Let's move on to the analysis. All right, so does anybody not have this set up the way that we have it right now? It's all good? All right, so once we have the raw data in there in this format, we can now start to actually run the analysis. So for this, we go to Analyze, and we head down here to Compare Means, and this Compare Means folder is where we're going to have all of our hypothesis tests. You can see how powerful SPSS is because it's got a ton of hypothesis testing procedures that you can use. But this is the intro to statistics. And here is where many of the tests that we use as psychologists are located. So in this intro to statistics, we're always going to go to Analyze. We're always going to go to Compare Means. And then we got to figure out which one of these is the t-test that we want to run. Now, sometimes SPSS is very friendly to you, as in this example here. So we're doing a single sample t-test. That's the type of t-test that we're working on because we got one sample of monkeys, single sample t-test. SPSS doesn't have anything called single sample t-test, but it does have one sample t-test. So again, that is what we're looking for. Single sample, one sample, same thing. So the correct test is this one sample t-test. So once more, you go to Analyze, you go to Compare Means, go to the one sample t-test, and we click on that, and it brings up the one sample t-test dialog box. So this dialog box is where we're going to do our final setup for the hypothesis test. All right, so is anybody not at the dialog box? It's all good? Okay. So the first thing we need to do is we need to tell SPSS what is the test variable. Where are our raw scores? Now for this example, it's going to be easy because there's only the one set of scores. But sometimes you'll be dealing with a spreadsheet or data that has a bunch of different scores. If that's the case, highlight the one that has your raw scores in it, that has the dependent measure for your subjects, your raw scores for your subjects. You highlight it and then you use this arrow to move it into the test variable window. If you make a mistake, you can use the arrow to move it back in, move back out, back in, back out, in and out. So we'll leave it in there right now. That's our test variable. That lets SPSS know where to find the numbers that it's going to use for this analysis, where to find those raw scores. All right, we got one more thing that we need to do. And this is by far where the most errors occur. So this is the danger zone. This is the hidden trap. This is where 95% of errors when students are learning the single sample t-test occur. And it occurs here for this test value. That test value has to be updated to be the value for your null hypothesis. your null hypothesis value needs to go in there. So our null hypothesis was that there was no difference between the wire mesh mother and the terry cloth mother's hours. They spend 18 hours in total together. That means that they should spend 9 hours with the terry cloth mother, 9 hours with the wire mesh mother. That means that we have to update this test value from 0 to the 9 hours. So your null hypothesis value has to go into the test value. And again, just make a note, this is where 95% of the errors in doing a single sample t-test occur. People forget to update that test value. So don't let that happen to you. Make sure that you update that test value to your null hypothesis. So we're going to test whether or not the scores for our terry cloth monkeys are any different than 9 hours spent with the terry cloth mother. Is it any different than 9 hours? That's our test value. Once we have that all set up, we can hit OK, and SPSS will run our hypothesis test. So does anybody not have this ready to go? All right, let's hit it. We hit OK. And SPSS has run our test in, how long did you take, SPSS? Oh, it didn't actually mention how long it took. All right. So SPSS has run our test, given us our output, and it's done. The number crunching, the math, all of those steps 2, 3, and 4, they're done. They're finished. SPSS has done that for us. All right. Does anybody not have this output? It's all good? All right. Okay, so that is SPSS's part. It has done its job. And now what we need to do is we need to interpret that and make our final conclusions. So SPSS has done its work. Now it's our turn to take over, and we need to analyze this output, analyze all these numbers, and make our decision for step number 5. So we need to find out if our sample t-score is beyond the cutoff t-score. If so, we're going to accept the research hypothesis and reject the null hypothesis. If, on the other hand, the sample t-score is within the cutoff t-score, we're going to accept the null hypothesis and we're going to reject the research hypothesis. So none of this has changed. We just have SPSS now doing all the heavy lifting. All right, so where do we find this information? Where do we find the information for steps 2, 3, 4 so that we can make our conclusion for step 5? Well, it's going to come from this output here. So let's take a closer look at this output. I've zoomed in. This is from a previous version of SPSS, so your numbers might be like slightly different, down in the 10,000. But it's the same format, same idea. So what do you want to do with this output? We got 2 tables of output. We got this top table here, one sample statistics, and then we got this bottom one here, one sample test. You always want to start by checking that top table, because that table lets you know or warns you if anything went wrong with your data entry. So SPSS has very nicely summarized the information that we've given it, and SPSS has told us that for the variable terry cloth, we gave it 9 scores. So we can say to ourselves, all right, we gave it 9 scores. Yeah, we had 9 monkey subjects in our study. Great, we're not missing any scores. So SPSS will let you know how many scores it has. Double check that and make sure it's the right number of scores. SPSS will tell you the mean that it calculated for those scores. So it has a mean of 15.3 hours. You can take a look at your Excel sheet. The mean for our scores is 15.3 hours. That gives us confidence that we didn't copy it incorrectly, we didn't paste it incorrectly. It's just a double check to make sure that we didn't start with the wrong numbers. So always check that, especially useful in an exam situation where you might be trying to go a little bit faster than you're used to, and it's easy to make these little slip-ups. Give yourself a second or two, double check it, and then you can proceed with confidence. All right. Also, I didn't mention it, we didn't have this calculated, but also it'll give you the standard deviation. Yet another check. So the standard deviation for our raw scores, right there. So again, this is just nice ways to check to make sure that you didn't miss any data. All right, so that was our check. Next thing, we got to do step 2. Determine the characteristics of the comparison distribution. We need the degrees of freedom for the comparison distribution because it's a t distribution, and we need our estimated standard error, the standard deviation of our comparison distribution. We need those 2 pieces of information. SPSS has very nicely calculated those 2 pieces of information. So let's start off with the test value. This test value right here, that's the mean of your comparison distribution. Importantly, this is the last thing you want to double check. Double check to make sure that your test value equals your null hypothesis. Because if it doesn't, your t-test is way off. You've compared it to the wrong number. So just double check this as well. Test value equals 9. Yep, 9 hours is what we wanted to compare our scores to, and we have compared it to those 9 hours. But what about our comparison distribution? Well, we have degrees of freedom and estimated standard error. SPSS has calculated both of those for us. So your estimated standard error, right there. That is the standard deviation of your comparison distribution. So that is what we learned how to do in chapter 6. And now that we know what it means, we actually have, we can actually hand that over, and SPSS can calculate for us, and we have it right there, calculated plain as day. The other thing we need is we need degrees of freedom. In the beginning, degrees of freedom is going to be rather straightforward to calculate. So we have 9 subjects. Degrees of freedom is going to be 9 minus 1, that's 8. But notice SPSS has calculated that out very nicely for us as well. So we have 8 degrees of freedom and a standard deviation of 1.73 for our comparison distribution. All right, next one. Set a cutoff score, sample score, or critical value. SPSS will not do this for you. So be aware that this is the one piece of information that SPSS will not give you in your output. So that doesn't mean that it's not going to help you a little bit, but you are going to have to do some work on your own. So SPSS is not going to do this. It will help you though, because it does give you the degrees of freedom. So remember that you need to know the degrees of freedom for your comparison distribution, because it's a t distribution and it changes shape depending upon the degrees of freedom. Once you have your degrees of freedom, you're ready to go to your t distribution appendix right here, and this is where you get your cutoff scores. So for this particular analysis, you need 3 pieces of information. You need the degrees of freedom. SPSS will give that to you. You need whether you're a one-tailed or a two-tailed test. That comes from the question. And you need to know what is your alpha level, what is your significance level. That also comes from the question. So you need those 3 pieces of information. And then in this table, you just hone in on the correct cutoff scores using those 3 pieces of information. So for example, we know from the question that we're doing a two-tailed test. So we know that we're in this area here of the table. We're not over here in one-tailed land. We're over here looking for a cutoff score for a two-tailed test. We also know that we have a degrees of freedom of 8, right? So we're here in two-tailed territory. And we also know that we got 8 degrees of freedom. So we know that we're in this row right here. And then our last piece of information is our alpha level. We have an alpha level of 0.05. That allows us to limit ourselves to this column right here, and we look where all of those intersect, and there's your cutoff score. So to read this table, you need those 3 pieces of information. One-tailed or two-tailed, how many degrees of freedom? SPSS will give you degrees of freedom. What is your alpha level? And then you can hone in on that cutoff score. So there's the cutoff score. This is table A2. This is in appendix A. This is the table right after the z distribution. All right, so we have that cutoff score, and it is plus and minus. So because this is two-tailed, we have our t distribution right here. T-distribution, just like a Z-distribution, has that mean of 0. And now we have our cutoff scores of positive 2.306 and our cutoff score of minus 2.306. So it's the exact same logic and setup that we're used to in hypothesis testing. All right, next part. We need to determine where is our sample on this distribution. So we know that our sample has a mean of 15.3. But notice that this is the transformed distribution. This is the comparison distribution, and it got transformed so it has a mean of 0. We got to transform our sample mean as well. Luckily, SPSS did this for us. So that formula where we're calculating out t-statistics, we don't need to do that anymore. We just need to know where to find that information. So we need to know where to find our t-statistic, our samples t-statistic, and that is right there. SPSS has calculated it out for us. We have a t-statistic of 3.637. If that's 0 right there, and that's 2.306, 3.637, right there. That's where Harlow's monkeys ended up. So they are either monkeys that prefer the terry clock mother, or sorry, they are either from a population that prefers the terry clock mother, or we just ended up with the 9 most terry clock mother loving monkeys in the world, right? It's one of those two. Either we have a really weird sample, or our sample doesn't belong to this population that doesn't prefer the terry clock mother. It's crossed the line. It's gotten too unlikely, too extremely weird for us to say that maybe we just ended up with the 9 most terry cloth loving monkeys in the world. No, we actually have monkeys from a population that actually prefer the terry cloth mother. So we have that here. I just want to point out that this number here is tied in directly to this significance value. This is the p-value. This is going to be very important coming up very soon. But I just want you to know that this number directly determines this number. And this number here directly ties into this number here. All right, the same way that the percentage here in this tail directly determines the cutoff score, the t-statistic directly determines your significance value there. But right now we're going to keep it straightforward. We're going to keep it the way we've been doing it before. If the sample t-score is beyond the cutoff t-score, we accept the research hypothesis and we reject the null hypothesis. Yes, our t-statistic put our mean beyond the cutoff score. So this is what we're going to do. We're going to accept the research hypothesis. On the other hand, if the sample t-score was within the cutoff t-score, then we would accept the null hypothesis and we would reject the research hypothesis. So if these monkeys ended up somewhere in here, then this is what we would do. So they crossed over and they passed by this critical value here. So they crossed over, we reject the null hypothesis, and we conclude, once again, that monkeys actually do prefer the terry cloth mother. So we've seen this one example a bunch of times now. This is the actual final real version of it. We built it up, kind of dropping assumptions as we've gotten more realistic. This is how this type of an experiment is actually run, and we find out that we get this same conclusion that we've been getting. The monkeys prefer the terry cloth mother. All right, so that was our intro to single sample t-test. That was our intro to SPSS. So what we're going to do right now is we're going to take 20 minutes break / practice time. Just want to let you know that if you, as you're working through, don't forget about your pre-test points. I'm going to be updating those and updating the grades and grading the exam very, very soon. And I just want to point out that there is extra practice. So maybe before you tackle your homework, just to get a little bit more confidence and a little bit more practice with these SPSS tests, you can find the questions in a practice PowerPoint file. So the questions and answers are in OA practice June 10th. The data can be found in the same Excel sheet. So here is the data. So we got demo question number 2, demo question number 3, demo question number 4, and then in a separate PowerPoint file, you will have the questions, and then you will also have the output and also the answers for each step along the 5-step procedure. So that is, part of your opportunities for practice, and just kind of will wrap up. Oh, and that was all I wanted to wrap up for this first hour. So it's 9:55. So let's take 20 minutes for a break / practice time. So we'll restart the class at 10:15. And if you have any difficulties with anything, if anything's not working, feel free to call me over. We will be using SPSS for the remainder of this semester. So this is your first intro, and let's make sure everybody has a good start to it.